Till now, we studied about linear equations in two variables. In this video today, we will study about quadratic equations and the standard form of quadratic equations. In the previous session, you have already studied about polynomials. Do you remember about quadratic polynomials? Can you tell what would be its general form? Very good. The general form of a quadratic polynomial is ax square plus bx plus c. Now let's understand quadratic equations. Can you tell how a quadratic equation looks? Consider the quadratic polynomial px equal to ax to the power 2 plus bx plus c. When this quadratic polynomial is equated to a constant, this polynomial gets converted into a quadratic equation. Here, a, b, c are all real numbers and a can never be 0. So based on this conclusion, let's try to understand quadratic equations. Mohan's father is 22 years elder to him. After 3 years from now, the product of their ages would be 270. What would be the equation for Mohan's current age? Let Mohan's current age be x years. Then, his father's age would be x plus 22 years. Mohan's age after 3 years would be x plus 3 years. And his father's age after 3 years would be x plus 22 plus 3, that is, x plus 25. Therefore, the product of their ages equals x plus 3 times x plus 25. Upon solving it, 270 is equal to x to the power of 2 plus 28x plus 75. We see that on the right-hand side, we have a quadratic polynomial and on the left-hand side we have a constant. Let's write the obtained quadratic equation in the standard form. We get x to the power of 2 plus 28x minus 195 equal to 0. Therefore, Mohan's present age satisfies the equation x to the power of 2 plus 28x minus 195 equals to 0. In this video, we studied about quadratic equations and the standard form of quadratic equations. Based on what we learned in today's video, we will solve some interesting examples in the next video. You all are welcome to this video. In the previous video, we studied about quadratic equations and the standard form of quadratic equations. Let's look at some examples based on it. Rita has a wooden plank with an area of 48 square feet and its length 2 feet more than the breadth. Rita has to construct a wooden frame with the plank. For this, she needs the equation of length and breadth of the frame. Will you help Rita find an equation that will be formed to find the length and breadth of the frame? Let's solve the example using the given information. To begin with, let's assume the breadth of the frame as x feet. So now, to find out the length of the frame, let's add 2 feet to x, which gives the length of the frame as x plus 2. We know that the wooden plank is rectangular. So, we use the formula for the area of a rectangle. It's given that the area of the rectangle is 48 square feet. Substituting all the values given above in the formula of the area, On solving, we get x raised to 2 plus 2x minus 48 is equal to 0. Using this equation, Rita can find out the length and breadth of the frame. Come on, let's look at one more example. A bus completes 160 km with a constant speed. If we increase its speed by 4 km per hour, then the bus takes 1 less hour to complete the journey. In this case, find out the equation to find out the speed of the bus. Can you find out the equation for speed of the bus? Let the speed of the bus be x kilometers per hour. The total distance covered by the bus is 160 kilometers. Let the time taken by the bus to cover the distance be t hours. Since we need to find the equation for speed of the bus, let's represent it in the following manner. Speed x would be equal to 160 by t, or we can write it as t is equal to 160 by x, which is represented by equation 1. On increasing the speed of the bus by 4 km per hour, we get x plus 4. According to the question, on increasing the speed of the bus, it takes 1 less hour to complete the distance. That is, time is equal to t minus 1. On solving, we get equation 2. Substituting the value of t from equation 1 in equation 2, we get x to the power 2 plus 4x minus 640 equals 0, which is the equation for the speed of the bus. In today's video, we looked at some examples based on quadratic equations and its general form. In the next video, we will look at some of the commonly made mistakes while solving such questions. You all are welcome to this video. In the previous video, we looked at some examples based on quadratic equations and its general forms. Now we will look at some of the commonly made mistakes while forming quadratic equations and its general form. The length and breadth of a rectangular garden is 10 meter and 12 meter respectively. If we increase these dimensions by the same amount, then the area of garden becomes 240 square meter. Find the equation for the rectangular garden. To solve this question, pause the video and match your answer. If you have selected option 1, then it is a nice try. But this is an incorrect answer. Because we had to make changes in both length and breadth of the garden, whereas you only made change in its length. And on its basis, you solved the question further, because of which your answer is wrong. If you selected option 2, then it's a good attempt. But this is also incorrect. Because to solve this question, you have increased the length and breadth. But while transposing the term on the RHS to the LHS, you didn't change the sign, due to which the answer is incorrect. Let's solve the equation. Transpose 240 in the RHS of the equation to the LHS and change its sign to solve it further. We get x to the power of 2 plus 22x minus 120 equals 0. This is the equation of the rectangular garden. Hence, option 3 is correct. So, I hope you understood why only option 3 is correct and the other options are incorrect. A teacher can test the knowledge of her students in a class by using such examples. I welcome all of you to this video. In the previous class, we studied about quadratic equations and its general form. Today, in this video, we will learn how to solve quadratic equations by factorization. You have already studied that a quadratic equation is ax squared plus bx plus c is equal to 0. Where the value of a is never 0, because then it will become a linear equation and not a quadratic equation. Can you tell the maximum number of solutions a quadratic equation can have? Very good. Can have maximum 2 solutions. How did you know this? A quadratic equation has 2 as the highest degree. Hence, a quadratic equation can have maximum 2 solutions. Do you know how to solve a quadratic equation by using factors? A sculptor makes some sculptures in a day. The cost in rupees of one sculpture is equal to the number of sculptures made in one day minus 70. On a particular day, the sculptures cost rupees 1800. Find the number of sculptures made that day. To find the number of sculptures, we first need to make a quadratic equation. Pause the video and match your equation. With the help of above information, let's solve the quadratic equation further. Let's break the middle term of equation minus 70 in two parts as minus 90 and plus 20. Therefore, on solving the quadratic equation x squared minus 90x plus 20x minus 1800 is equal to 0, we can write the equation 2 as a product of its factors as x plus 20, x minus 90. On solving further, we will equate each of the linear factors to 0, which gives us x plus 20 is equal to 0 or x minus 90 is equal to 0, that is, x is equal to minus 20 or x is equal to 90. Therefore, x is equal to minus 20 and x is equal to 90 are the solutions to the given quadratic equation. Since we need to find the number of sculptures made and it cannot be negative, hence, there were 90 sculptures made that day. On substituting the value of x as 90 in equation 1, we get it equal to 0, which proves that our answer, x is equal to 90, is absolutely right. In this video, we learned how to solve a quadratic equation by using factorization method. We will practice what we learned today in the next video. You all are welcome to this video. In the previous video, we learned how to solve a quadratic equation by factorization. Today, we will take an example based on this method. After looking at a rectangular box, Hardik asks his father how much is the breadth of this box. To which his father says he doesn't know the breadth, but he knows that the breadth of the box is 12 centimeter, less than twice its length, and that the area of the box is 32 square centimeters. So can you find its breadth? Will you help Hardik to find the breadth of the box? First, let's assume the length of the box to be x centimeter. Then, to find the breadth, we need to double the length. On subtracting 12, we get 2x minus 12. We know that since the box is rectangular, we can use the formula for area of rectangle. Here, the area of the box given is equal to 32 square centimeter. Putting all the above values in the formula of area, we get 2x square minus 12x minus 32 is equal to 0. Can you find the value of x from this quadratic equation? For the value of x, let's select a term in equation 1, which is the middle term of the equation. Hence, let's split the midterm, which is minus 12x is equal to minus 16x plus 4x. On solving, we see that x minus 8 is equal to 0 or 2x plus 4 is equal to 0. Hence, we get x is equal to 8 or x is equal to minus 2. Therefore, x is equal to 8 or x is equal to minus 2 are the solutions for the given quadratic equation. Since we are calculating length of a box, so it cannot be negative. Therefore, the length of the box would be 8 centimeter and breadth would be calculated from 2 multiplied by 8 minus 12 is equal to 4 centimeter. Today we looked at an example based on solving quadratic equations by factorization. In the upcoming video, we will look at some of the commonly made mistakes while solving such questions. Welcome to this video. In the previous video, you saw an example based on solving quadratic equations by factorization. Now we will look at some commonly made mistakes while solving a quadratic equation by factorization. Solve the given quadratic equation minus 5x plus 2x square is equal to 3 by factorization method. Pause the video and solve this question. If you selected the first option, then it's a nice try. But this is an incorrect answer because before solving a quadratic equation, you didn't write it in its general form, because of which it is impossible to solve this quadratic equation. If you selected the second option, then it's a nice try. But it is an incorrect answer because you solved the question without converting it into the general form. Which is why your answer is wrong. If you selected option 3, then it is a nice try. But this is also an incorrect answer because you learned in the last video that to solve a quadratic equation by factorization, it is important for the equation to be in its general form. Wrote the quadratic equation in its general form and splitted the middle term of the equation. On solving, we get two linear factors is equal to 0. And putting each linear factor is equal to 0. But you didn't change the signs while solving equations 1 and 2. If you chose option 4, then it's the correct answer. Putting each linear factor of this quadratic equation is equal to 0. And changing the signs while solving equations 1 and 2. On solving it, we get a unique solution for the quadratic equation. So, we hope you understood why option 4 is correct and the rest of them are incorrect. A teacher can test the knowledge of his or her students by using such examples.
Hello everyone, welcome to this video. In our previous video, we learned to find out the solution of a quadratic equation using the factorization method, in which the middle term is in the form of bx, coefficient b of x is equal to the sum of two factors and the product of a and c. In this video, we shall see how to solve a quadratic equation by completing the square. Can you solve a quadratic equation using the factorization method? For example, here we are given a quadratic equation. Can you solve this equation using splitting the middle term method? If we try solving this equation using splitting the middle term method, we will not succeed as we cannot factorize the equation. Let us now solve the quadratic equation. X square plus 6x plus 3 equals to 0 by another method. How many terms can you see in the given equation? Absolutely right. This equation has 3 terms. Let us observe them. Talking about the first term of the equation, let it be a square, each side of which is x, whose area is the x square. Similarly, looking at the second term of the equation, suppose it is a rectangle, which has one side 6 and other side x, whose area is 6x. Can you combine these two shapes to form a new shape? Well done! If we combine the given square and rectangle, we shall get a new rectangle whose area will be equal to the sum of the area of the square and the area of the first rectangle, which means that its area would be x to the power 2 plus 6x. Now, we can divide the small rectangle, which is part of the new rectangle, into two equal rectangles in this manner. Now, let's arrange the rectangular pieces in this way. On doing so, we get a new shape from this, whose total area is still equal to x square plus 6x. We can say that this shape is neither a square nor a rectangle. Can you guess what should be done to complete the shape as a square? In order to complete the shape, we need a square piece of side 3 units. Let's add a square piece of side 3 units to the figure. On doing so, we get a square, whose each side will be x plus 3 and its total area will be x plus 3 the whole square. To retain the area of the figure x square plus 6x, we will subtract the area of a square piece of side 3 units, which is 9 square units. Thus, the expression x square plus 6x can be written as x plus 3 the whole square minus 9. On comparing the given equation to the quadratic equation, x square plus 6x plus 3 equals to 0. We see that there is a shortage of plus 3 in equation 2. Hence, adding 3 to both sides of equation 2, which can be expressed as in this way, the given equation can be written as a complete square as x plus 3 the whole square minus 6 equals to 0. Can you now find the value of x by solving equation 4? Well done! If we take the square roots of both the sides of equation 4, we get x plus 3, which is equal to plus minus root 6. Can you tell me, why didn't we just consider positive root 6? That's because the square of both positive root 6 and negative root 6 is 6. Therefore, on solving the roots of the equation, x is equal to minus 3 plus square root of 6, and x is also equal to minus 3 minus square root of 6. Thus, we have found the root of the given quadratic equation by expressing it in the form x plus 3 the whole square minus 6 equal to 0. In the same way, we can solve any quadratic equation by converting it the term minus b square by 4a into a perfect square and finding the solution of a multiplied by x plus b by 2a the whole square plus c minus b square by 4a equal to 0. This method is known as completing the square method. In this video, we learned how to solve a quadratic equation by completing the square method. In the next video, we shall see examples related to it. Hello everyone and welcome to this video. In our previous video, we learned how to solve a quadratic equation using completing the square method. In this video, let us solve a few problems based on this method. A rectangular garden is 12 meters in length and 10 meters in width. If all of its dimensions are increased by equal number, the total area of the garden becomes 240 square meters. Find the solution of the equation of the rectangular garden. Can you find the equation of the garden? Pause the video here and find out the equation of the garden. Do you remember how we had solved a similar equation in the previous video? Well done! We can solve this by completing the square method. First and foremost, we see that the equation is not in the form of perfect square. To simplify it, let us move its constant to the right side. Now, if we divide the coefficient of x in equation 1 by 2, we get 11. Let us add and subtract the square of 11 to the left side of equation 1 to keep the equation balanced. When we solve this equation, we get x square plus 22x plus 121 equal to 241, which can be represented in the given manner in equation 2. Can you find the solution of this equation, that is, the value of x? Well done! In order to solve this, the square root sign will be applied to both sides of equation 2. We will get the value of x plus 11 as plus or minus root 241. On solving equation 1 and 2, we will have the same roots. Thus, if we take the positive sign, the value of x will be 4.52. And if we take the negative sign, the value of x will be minus 26.52. Here, we get two values of x. However, dimension of the garden cannot be a negative value. Therefore, the increase in the measurement of length and width of the garden will be 4.52 meters. Let us look at another example. Madhu's age is 8 years less than 4 times Raghu's present age. If the product of the ages is 60, then can you find the present age of Raghu and Madhu? Suppose Raghu's present age is equal to p years. According to the question, Madhu's age is 8 less than 4 times Raghu's present age. That is, Madhu's age will be equal to 4p minus 8 years. The product of both their ages is given as 60, which we shall consider as equation 1. Solving equation 1, we get equation 2, which is 60 equal to 4p square minus 8p. Simplifying equation 2, we get equation 3. If we divide the coefficient of p in the equation 3 by 2, we will get 1. Adding and subtracting the square of 1 on the left side, we can balance the equation. Thus, we get the equation p square minus 2p plus 1 is equal to 16, which can be written as equation 4. Note that the solution of equation 1 will be the same as that of equation 4, which gives a value of p minus 1 is equal to plus or minus 4 after solving. Thus, if we take the positive sign, the value of p will be 5, and if we take the negative sign, the value of p will be minus 3. Therefore, both the solutions of p, that is 5 and minus 3, satisfy our equation. But if we wish to find out the age of Raghu and Madhu, and age cannot be a negative integer, therefore we will take the value of p as 5. Thus, Raghu's age will be 5 and Madhu's age will be 12 years. The method which we have used to find the age of Raghu and Madhu is called completing the square method. In this video, we have learned how to solve a quadratic equation using completing the square method. In the next video, we shall see the common mistakes that are made while solving such equations. Hello everyone and welcome to this video. In the previous video, we saw some examples solving a quadratic equation using completing the square method. Now we shall see what are the most common mistakes that happen while solving a quadratic equation by completing the square method. The sum of the marks that Hardik got in mathematics and science exams is 44. If he gets 2 marks more in mathematics and 4 marks less in science, then the product of his marks is 440. Can you find out marks he got in each subject? Pause the video to solve this question and then check your answer. Let us suppose that the marks obtained in mathematics is x, therefore the marks obtained in science will be 44 minus x. We know that if we add 2 to the mathematics marks and subtract 4 from the science marks, the product of the marks becomes 440, which is shown by equation 1. Upon further simplifying, we get algebraic equation 2. Can you guess what we should do next? To find out the mathematics marks, we will solve equation 2 in which coefficient of x is minus 38 and we divide it by 2. Thus, we get minus 19. We will now add and subtract the square of minus 19 to the left side of equation 2 so that the equation remains balanced. Solving the equation further, we get two values of x. X is equal to 18 and x is equal to 20. If we take the value of x as 18, then we get 18 marks in mathematics and 26 marks in science, and these satisfy the conditions given in the question. And if we take the value of x as 20, then we get 20 marks in mathematics and 24 marks in science, which once again satisfies the given conditions. So we can say that there are two possible solutions to this question, 18 or 20, and that Hardik could have got either of these marks. Hence, option 3 is the correct answer. If you have chosen the first option, it is a good try. But this answer is wrong. Because when you take the square root of x minus 19 square is equal to 1, then you only consider that x minus 19 equals to plus 1, which gives 20 marks in maths and 24 in science. But you have forgotten that x minus 19 equals to minus 1 is also a second possible solution. Note that we have to find the value of x for both positive and negative 1. Therefore, option 1 is incorrect. If you have chosen the second option, this too is a good try. But once again, your answer is incorrect. Because when you divided 38, the coefficient of x in equation 1 by 2 and then added and subtracted it directly to the left-hand side of the equation and get this equation without taking the square of 19 and then doing the same. In this way, we get stuck here because we had made a mistake while making the perfect square due to a wrong understanding, because of which you get an incorrect answer. So hopefully you must have understood why the third option is right in this example and why the other options are wrong. Teachers can also test the understanding of students in the class with the help of some such examples.
Welcome to this video. In our previous video, we learned to solve the quadratic equation by completing the square method. Today, In this video, we will learn to solve the quadratic equation by using the quadratic formula. We know that this is a general form of the quadratic equation.
To solve this equation by completing the square method,
first, we divide the equation by a to make the coefficient of x to the power 2 as 1. Then,
to make a perfect square, we divide the
coefficient of x and increase it to 2 powers. We will add and subtract the value obtained into the equation so that the equation is balanced. This is equation 2. On solving equation 2, we get b to the power of 2 minus 4ac upon 4a to the power of 2 on the right side. And by expressing the left side as the square of a binomial, we get this form of the equation. What do we need to solve this equation? We find the square root of the equation,
keeping in mind that in the right side of the equation, we put a positive and negative sign.
Because when we square 3 and negative 3, we get positive 9. But when we take the square root of 9, then positive and negative 3 are obtained. So on solving equation 3, we get this equation. Now keeping the variable x to the left, the constant term b over 2a moved to the right side. On simplifying this, we can see that we get x is equal to minus b plus or minus root of b square minus 4ac by 2a, which is represented in equation 4. If b to the power of 2 minus 4ac is greater than and equal to 0, then this gives two real roots of the quadratic equation ax to the power of 2 plus bx plus c equals 0. And if b to the power of 2 minus 4ac is smaller than 0, then the real roots are not obtained. Therefore, to find the roots of any quadratic equation, we can use this formula, which is called the quadratic formula. Can you tell which Indian mathematician had successfully tried to find the quadratic formula? The quadratic equation was solved by the mathematician Sridharacharya, which is called the quadratic formula or Sridharacharya formula. In this video, we learned to solve the quadratic equation by using the quadratic formula. In the next video, we will see some examples related to it. Welcome to this video. In the previous video, we learned about quadratic formula. Today, we will see some examples based on it.
Tarun spent 4 hours on a ship where the water flow was 3 kilometers per hour and the ship ran 20 kilometers downstream and 20 kilometers upstream. When he came back, he sees the captain writing some math equation on paper. When he asks him, "What are you doing?" then the captain said that the ship's speedometer is damaged. So he is trying to know the speed of the ship. Will you help the captain in determining the speed of the ship?
First, let's assume that the speed of the ship is x kilometers per hour. According to the example, the flow of water is 3 kilometers per hour, where the speed of the ship favorable to the stream is equal to x plus 3 kilometers per hour, and the speed of the ship unfavorable to the stream is equal to x minus 3 kilometers per hour. The ship moves 20 kilometers favorable to the stream and 20 kilometers against the stream. So the time taken by the ship to go favorable to the stream is equal to 20 by x plus 3, and the time taken to go against the stream is equal to 20 by x minus 3. According to the question, Tarun spent 4 hours on the ship. That is, by simplifying the above equation, we get 40x equal to 4x to the power of 2 minus 36. It is denoted by equation 1, which is a quadratic equation. You must remember what did we do in the previous video to solve this type of question. Well done. For this, compare equation 1 with the general quadratic equation, where a equals 4 and b equals minus 40 and c equals negative 36. Place the values of a, b and c in the quadratic formula that is in equation 2 and solve. On solving, we get x equals 5 plus and minus 5.83. That is, x equals minus 0.83 or x equals 10.83. Because x is the speed of current, therefore it cannot be negative. Hence, we leave the value x equals minus 0.83. So we get from x equals 10.83 that the speed of the ship is 10.83 kilometers per hour. Today, in this video, we learn to solve a quadratic equation by the quadratic formula. In the following video, we will see what can be some common mistakes while solving these types of questions. Welcome to this video. In the previous video, we saw examples of quadratic equations based on the quadratic formula. Now, we will see what common mistakes we do while solving quadratic equations by the quadratic formula. Two car drivers drive on two perpendicular paths from a city at 20 kilometers per hour and 40 kilometers per hour respectively. The second car driver starts the journey an hour later than the first. Can you tell after how long the distance between the two will be 100 kilometers? Pause the video while solving the question and then match your answer. Let us express the given information in algebraic form. Hopefully, you have also made the same quadratic equation. Find the time taken by the driver using the quadratic equation. First of all, we will write the values of a, b and c by comparison to the standard quadratic equation, where the value of a is 5, the value of b is negative 8 and the value of c is negative 21. By solving all the values in the quadratic formula, by taking the positive sign, we get the value of t as 3 and by negative sign t as negative 1.4. You know that time is never negative, so the value of t will be 3. That is, the first car driver will take 3 hours to cover the distance. And the second driver, which was delayed by 1 hour compared to the first driver, will take 2 hours. Hence, option 3 is the correct answer. If you have selected option 2, this is a good try, but it is the wrong answer. Because when you compare the values of A, B, and C in the quadratic formulas with the quadratic equation 1, you forget to put the signs of these values and solve the question with the same values. Here, we solve b to the power 2 minus 4ac. So the values are less than 0, which does not give the real time, because of which your answer is wrong. If you have selected option 1, it is a good try, but this is also the wrong answer, because you have written a positive b instead of a negative b in the quadratic formula, and solve the question based on that. Because of which your answer is wrong. So hopefully you must have understood why the third option is right in this example and why the other options are wrong. Teachers can also test the understanding of students in the class with the help of some such examples.
Welcome all of you to this video. In the previous videos, we have understood the factorization method, completing square method, and quadratic formula for solving quadratic equations. Today, in this video, we will study the nature of the roots of a quadratic equation. Can you say what will be the general form of a quadratic equation? ax square plus bx plus c equal to 0 is the general form of a quadratic equation. We saw in our previous video that roots of a quadratic equation can be obtained with the help of the quadratic formula. Do you know what will be the nature of roots of a quadratic equation? Are they real or imaginary? Let's see how we can find it. In this quadratic formula, if the value of b square minus 4ac is greater than 0, it is a positive number. Let's consider it m. Now in roots derived from quadratic formula, let b square minus 4ac be replaced with m. Can you say what is the square root of a real number? Absolutely right. The square root of a real number will be a real number. And we know that adding, subtracting, multiplying, or dividing any real number with a real number always gives a real number. So b square minus 4ac being larger than 0, that is being positive, you can say that the quadratic equation will have two unequal real roots. Similarly, if we consider b square minus 4ac as 0, can you say what would be the nature of the roots of the quadratic equation? If in the roots obtained from case 1, we substitute 0 in place of b squared minus 4ac, then we get two equal real roots, that is x equal minus b divided by 2a. Can you think of any other case? Absolutely right. Now if we take the value of b squared minus 4ac less than 0, that is negative, let us assume it to be minus m. Again, if we substitute b squared minus 4ac equals to minus m in the roots obtained from case 1, then you will observe that we get a negative number under the square root sign. Can you find the square root of a negative number? The square root of a negative number is not real, hence it is imaginary. And we know that by adding, subtracting, multiplying or dividing any imaginary number with a real number, the result is always an imaginary number. So, in the case when b squared minus 4ac being less than 0, that is being negative, you can say that quadratic equation will have no real roots or it will have two imaginary roots. You have seen that for any quadratic equation, b squared minus 4ac determines whether the roots of the equation are real or imaginary. Therefore, it is called the discriminant. Today we saw that for a quadratic equation, if the discriminant b squared minus 4ac is greater than 0, that is positive, then the equation will have two unequal real roots. Is equal to 0, then the equation will have two equal real roots. Is smaller than 0, that is negative, then the equation will have no real roots or two unequal imaginary roots. In the next video, we will see some interesting examples based on this. Welcome to this video. In the previous video, we learnt about the discriminant and nature of roots of the quadratic equation. Today we will see some interesting examples based on this. The number of pens with Sohan is 3 less than the number of pens with Mohan, and the product of the number of pens is 28. Is this possible? Pause the video and write the quadratic equation for this situation and then match it with the video. Can you guess how to begin with the solution? Correct. First, we have to compare this equation with the standard form of the quadratic equation, which gives us the values of a, b, and c. What do we have to do now? Now, we have to find out the nature of the roots to check the possibility of the situation given in the question. How can we determine the nature of the roots? For this, we need to find the discriminant of the quadratic equation, that is, b squared minus 4ac. On substituting the values of a, b, and c, we get the value of discriminant to be 121. Based on this, can you tell the nature of roots of the given quadratic equation? On observing, we can see that the value of discriminant is greater than 0. And we know that if value of the discriminant of a quadratic equation is greater than 0, then that equation has two unequal real roots. So the quadratic equation x squared minus 3x minus 28 equal to 0 has two unequal real roots. Hence, we can say that this situation is possible. Let us look at another example. While learning the quadratic equation lesson, Jaya saw the equation 2x squared plus kx plus 8 equal to 0. Seeing this, she asks her friend Jay a question. The question was, for which value or values of k will the quadratic equation have imaginary roots? Jay says, it's very easy. I will solve it now. First of all, by comparing this equation broadly with the standard form of the quadratic equation, we get the values of a, b, and c. We know that the roots of quadratic equation will be imaginary if the value of its discriminant is less than 0, that is, negative. If we substitute the values of a, b, and c in this and solve, we get that k is greater than negative 8 and smaller than positive 8. So, for every value of k greater than negative 8 and smaller than positive 8, the quadratic equation 2x squared plus kx plus 8 equal to 0 will have imaginary roots. In this video, we have seen some interesting examples based on discriminant of the quadratic equation and nature of roots. In the next video, we will see the common mistakes that arise while solving these types of questions. Welcome to this video. In the previous video, we saw some interesting examples based on the nature of roots of a quadratic equation. Today, we will see what common errors occur while solving such questions. Nandini, Rekha, and Sushma saw a question given in the newspaper with a note saying, anybody solving the question correctly will win a reward. Sushma, Rekha, and Nandini select options 1, 2, and 3 respectively. Can you tell whose answer is correct and why? Pause the video to solve the question and then match your answer. You will see that the quadratic equation given in the question is not in its standard form. Can you write this equation in its standard form? The given equation can be written in the standard form as follows. On comparing it to the standard form of a quadratic equation, we can obtain the values of a, b, and c. What do we have to do further? In order to know the nature of roots, we have to discuss the discriminant of the quadratic equation. On substituting the values of a, b, and c in b squared minus 4 ac, we get 0. Can you tell what does it mean? We know that if the value of the discriminant of a quadratic equation is 0, then that equation has two equal real roots. Hence, Rekha's answer, that is option 2, is the correct answer. Sushma solved the question correctly and found that the quadratic equation would have two real roots, but she forgot to mention whether those two real roots would be the same or different. Due to which, Shushma's answer, that is option 1, went wrong. Nandini found out the values of A, B and C without writing the equation in the standard form and solved the discriminant by substituting the values of A, B and C in it, from which she got the value of discriminant less than 0, and hence she concluded that the given quadratic equation will have imaginary roots. Therefore, Nandini chose option 3, which is incorrect. Hope you must have understood why in this example, option 3 is correct and rest all are incorrect. Teacher in the class can also test the understanding of the students using such examples.